All right, BCA 101, we just finished up Units 1 and 2. We're just starting Unit 3. And at the end of Unit 2, we talked about security. And they were supposed to, the students filled in a discussion post, so we talked a little bit about that. They said things on the internet. I reminded them maybe use the term online to better indicate that rather than actually in the internet. We talked about hackers, good hackers, bad hackers, what they do, and how that term's used. And we cover that more thoroughly in the networking unit. They said, you know, all this social networking is bad for everyone. Well, only those people that use social networking. There was a great example about a picture, and you could see things in the background of the picture which told a potential thief what to steal, and it did happen later on when they were on vacation. Personal information, you know, you decide what personal information you're going to put in the social network. Some places there's information about us that we have no control over. Okay, you know, NIACC, you have to give them information. Your insurance company, banks have information, Department of Transportation, government, Social Security, IRS, and then you can name lots of places where you have to give them information and you have to trust them that they're going to take care of it. There are records kept on us, like if we have violations and so forth. There's records on property, if you own property. You know, do you give out information? You know, like Amazon, we talked about, they can keep your credit card, not your social security number necessarily, but they have your credit card number if you want them to have it, so you trust them to protect it. Same thing with PayPal. You can have that information there, then use PayPal to pay for things, but you have to trust them to take care of your information. And then over here, we just mentioned, where would you rather have them? Steal your credit card or your social security number? And nowadays it seems like the worst thing would be your social security number because of identity theft. If they get your credit card, if you monitor your credit card, you can always cancel that. But if they steal your identity and open new credit card accounts, you will not know what they're charging to those new accounts. Alright, so I think I'll go to the next page, talk about the things here to the right. Okay, now here we start talking about binary digits. I went through and explained base 10 and base 2. We talked about 10 to the 0, which is 1, 10 to the first is ones, or tens, 10 to the second is hundreds, thousands, 10,000, and we have an infinite number of numbers we can talk about. So in this case, I wrote a number in here, 1,035. One group of 1,000, 0 groups of 10, 3 groups of 10s, no groups of 100, excuse me, and 5 groups of 1. Then we compared it to binary base 2. And here we have, for binary, that was 2 to the 0, which is 1. 2 to the first is 2, so that's 1. Then 2, and 2 to the second is 4. Then 8, then 16, 32, 64, 128. And why that's important, we talked a little bit about when you read a number like 64K, or 64K bytes, or 64 kilobytes, kilo is really 2 to the 10th, which is 1024. So when we see these numbers, and we see them that they're not exactly 1,000, that's why. Everything is base 2. Then we went and started talking about, so we talked about digits, bits, bytes, ASCII code, and so forth. We've already talked about it. Then we started talking about the processor. And the processor word size. So you might see nowadays 64 bits, 32 bits, and years ago it was probably as small as 4 bits. And those numbers come from base 2. In a processor, we have registers in which the information is stored, high-speed storage areas in the processor, and we have an arithmetic logic unit that actually does the arithmetic and makes logical decisions. So software allows us to do this, allows us to make logical decisions and do all kinds of arithmetic. And it does it relatively fast, and we'll talk more about that later on. On that motherboard, down in the computer, we have memory and RAM, which is really important. We talked about clock speed, virtual memory, and how important those are. Also in there is ROM, cache memory, flash, bus, graphics cards. And we can cover a little more detail of that on Wednesday. But this virtual memory, the idea of paging is a term used, or swapping, they'll call it a page file or a swap file. That is, and I'll use a different color here, that's stored on that hard drive, but it acts like memory. When memory up here starts to fill, some things are kept on the hard drive. And then the information in memory is sent to the processor and then back. So in order for the processor to work on anything, it really needs to be in RAM. Whether it's your document or your software working with the document, plus the operating system is also in there. When that starts to fill up, you'll notice the performance of the computer to slow down, and then especially slow if it has to go out to the hard drive and bring that information back in. This movement right here is like a turtle compared to the movement in here. It's like a jet airplane. Alright, one other factor is the computer can process so many items, or move information from memory to the processor, process and send it back in so many clock cycles. And that's where we get then this gigahertz. Nowadays most of them are gigahertz, but it was slower years back. And for example, maybe your computer has 2.5 gigahertz clock cycle, 2.5 billion cycles per second. So that's clock cycles. Everything going through that motherboard is measured on clock cycles. So the higher the number here, the faster it can move the stuff through. But that is not as much a key factor as making sure you have enough memory. And we're going to review that on Wednesday. So, that is a little review from the notes we had on the board today.